This is New Directions in Enrichment and Acceleration by Shirley Shiver and C. June Maker, Chapter 12, Session 8, with Laura Campen and Libby Byrnes.
So today we're going to be talking about our overview of our chapter. We're going to talk about the definition of giftedness, what it means to be enriching your curriculum, and the research on enrichment. We're going to be talking about acceleration, where there's research on acceleration, enrichment and acceleration as complementary program components, the catastrophe theory and curriculum for gifted students, and curriculum for the gifted, which involves problem solving in the curriculum, types of problems, problem solving as a structure for curriculum, and curriculum development.
Okay, first, as most of our chapters have started, we have our definition of giftedness. So Maker-Nielsen's definition of giftedness is the ability and willingness to solve complex problems in a variety of domains and in a variety of ways. We learned from Gardner and Sternberg that they have theories of intelligence that give us insights into different areas in which people can be gifted. Gardner's multiple intelligences include linguistic, logical, mathematical, spatial, interpersonal, intrapersonal, musical, bodily, kinesthetic, naturalist, spiritual, and existential, while Sternberg's intelligences are analytic, synthetic, and practical.
So when we're talking about enrichment, we're referring to when Shiver and Maker include curriculum as a program delivery services. They define enrichment as richer, more varied educational experiences that challenge and offer growth in the area of the student's giftedness. So students need to be going into greater depth to truly understand the concepts that are being taught, so that they use a systematic plan such as the Odyssey of Mind and the Science Olympics.
Okay, Howley, and Pendarvis describe the following approaches to enrichment. So first is process-oriented. This is using a process like Bloom's taxonomy to develop a student's higher order thinking skills. This is taught in isolation from content, which is a disadvantage because it hinders the transfer to other content areas. Next is content-oriented. This focuses on a specific content area, such as mini courses, museum and science center programs, college options for free college students. This would be like putting an elementary student in like a pre-algebra mini course before they even get to the course. The problem with this enrichment is that it's separated from the curriculum, which causes a disruption in the logical progression of the content. So whereas an elementary student is already learning about symbols for pre-algebra while they might be learning about long division. Last is the product-oriented approach. The primary purpose is to focus on the result or the product rather than the process or the content involved. So this is like reports, presentations, or can even be something like coping mechanisms. The disadvantage here is that students are more focused on completing the product rather than establishing a knowledge foundation.
So the research on enrichment is that curriculum models that integrate content, process, and product, for example, we've read about these models, but parallel curriculum model, school-wide enrichment model, autonomous learner model, group investigations, and problem-based learning, which we've read about most of these. But grouping programs that involve more substantial adjustment of the curriculum to ability have clear positive effects on the children. And studies have shown that by having a pull-out program where students go to a separate classroom to be using their gifted skills, that they outperform their peers. So typically they're going to be like 4 or 5 months ahead of their peers academically, so that they're really enriching and digging deeper when they're learning.
Okay, acceleration is the next section, and it encompasses both curriculum delivery and service delivery. So curriculum delivery is going to be where you speed up the pace in which the material is presented and or expected to be mastered. An example of this is telescoping curriculum, which allows more material to be covered in less time, and students can have a self-pacing option. This allows students to master material rapidly, and they feel accomplished because they did it themselves and they have an independent achievement. And then the disadvantages lie for mostly teachers because it includes their requisite skills and time needed to telescope curriculum and create the actual self-paced content for individual students. The service delivery offers a standard curricular experience to students at a younger than usual age or a lower than usual grade level. So this would be early entrance to kindergarten or first grade. It allows students to complete schooling at a relatively young age, leaving more time for career and professional development. They found that sometimes students experience frustration due to their psychomotor development and they don't have intellectual peers to kind of talk about. So a gifted 5-year-old can't really hold a conversation with like a regular 5-year-old. The second one is grade skipping, and this has economical advantages, but the physical disadvantages for gifted students, such as athleticism, heavily influence their self-esteem.
So the research on acceleration, we focused on the researcher Van Tassel-Baska, which found that the advantages of the acceleration are that it improves motivation and confidence and scholarship, prevention of lazy mental habits, early completion of professional training, and reduction of cost education. Basically, the students are able to move more fluidly and independently, and so they're really challenging themselves and they're not feeling that the content is boring or that they're not able to really challenge themselves. But the disadvantage of acceleration is that it's difficult for students to adjust socially. A lot of times they have a hard time relating to their peers, possibly because if they're accelerated, they're not with peers that are their age. So socially it can hurt them, as well as it can have or cause gaps in their skills in certain core areas, which can affect them with not having some of the core areas like a strong foundation. So.
Okay, next, enrichment and acceleration as complementary program components. Basically, the important part of this is that enrichment and acceleration kind of have to exist together to get the optimal benefits. So abstract and complex concepts should be taught, which would be enrichment, and students proceed at a pace that is more rapid than that of the average learner, which is your acceleration in their areas of giftedness. Again, Van Tassel-Baska stated that the term enrichment has no meaning for the gifted unless it is intertwined with acceleration practices.
The catastrophe theory and curriculum for gifted students. So the catastrophe theory is a mathematical system that was developed by Renee Tom that accounts for any abrupt changes in nature of objects. For example, if water is changing into steam, that shows an abrupt change, which represents that more is becoming different. So the catastrophe theory, when it relates to curriculum, is that it's accelerated and enriched to the point where it becomes quantitatively differentiated. So when one recommendation in increasing the level of abstractness for students is by spending time on the concepts that relate to the big ideas, there is an emphasis on higher levels of thinking. Students should engage in these higher levels of thinking during the process, such as critically examining, synthesizing, and evaluating ideas, which should result that their product should reflect this enrichment and acceleration so that they can really be showing that they're not only digging deeper, but they're also moving at a quicker pace when they're learning the content.
Okay, so curriculum for the gifted. The experts who have studied this agree that curriculum for gifted students should be differentiated from that offered to other students according to the needs of the individual. So this chapter presented problem solving as an approach that encompasses the roles of enrichment and acceleration in developing curriculum for gifted students. There's types of problems developed by Getzels and this other lovely man. And they developed a distinction between a presented problem and a discovered problem. Basically, your presented problem has a known formulation, method, and solution. And this would be like your typical math problem. And then a discovered problem does not have the formulation, method, and solution to be known. So that's kind of like your more abstract conceptual questions.
So there's 5 different types of problems, as you see are listed in table 12.1. But basically, if you look at the table, there's type 1, 2, 3, 4, and 5 problems. And you see that there's the problem, and some of the problems are known, and some of the problems are unknown depending on who you are. So if you're the presenter in type 1 problems, you know the problem, and the solver knows the problem. They know the method, both of them, the presenter and solver, and they also know the solution is known to the presenter but not the solver. They have to solve the solution. Whereas you see with type 5 problems, nothing is known. They don't know the problem, they don't know the method, and they don't know the solution. So we see the range of difficulty of type 1 problems are easier than type 3, 4, and 5 problems. So if the goal of the curriculum is to prepare students to become problem-solving adults, then they need to make sure that they're not just practicing type 1 problems, but practicing type 2, 3, 4, and 5 problems, so that they can really make sure that they problem solve, and they're not just always expecting the answer to be known with a problem and a method already known.
Okay, so breaking down the problem solving as a structure for curriculum, your type 1 problems are going to use recall and classification. So asking students to list 5 ways in which a person can take care of themselves. Pretty basic, your lowest level. Then you have type 2 problems, which use defining and evaluating. So this would be asking students to extend self-care to the family and potentially collaborate with other students in the class to develop a ranking system for kind of where those responsibilities fall. Type 3 problems use developing, analyzing, and evaluating. So for example, asking students to develop their own scenarios about accepting responsibility for the consequence of one's actions and kind of following up with class or partners. Type 4 problems use analyzing, evaluating, and generalizing. So this would be asking students questions where the methods and solutions are unknown. For example, how we might determine the necessary components of a functional society. So the problem is known, but the methods and the solutions would be unknown there. Type 5 problems use defining the problem, engaging, drawing conclusions, making decisions, examining critically, and evaluating. For example, asking students to identify the problem and determine its solution. These type 5 problems are really going to encompass all those higher levels of thinking. An example would be asking students what current issues are related to personal responsibility. So again, those abstract and complex ideas are at play.
So curriculum development, when we're talking about curriculum development for enrichment, when planning a curriculum, teachers should have a variety of problem types like we've already talked about. It has shown that it increases the amount of enrichment when we use problems types 3, 4, and 5. It helps to enrich the content. In order to facilitate the progression towards abstract and complex thoughts, teachers need to incorporate higher levels of thinking and problem solving in their instructional plans. When we're talking about acceleration for curriculum development, teachers can present more abstract ideas at an earlier age for gifted students, and gifted students can move quickly or more quickly through the information in their area of giftedness rather than other students that might be their same age.
So our discussion question for you guys is to think about a lesson that you've taught in the past year. Select one activity in the lesson and explain how you could use problem types 2 through 5 to either accelerate or enrich the process, content, or product for the gifted students. Do you think this would be difficult to apply this to all lessons? And do you think collaborating across content areas would help or hinder student development in terms of enrichment and acceleration?
Okay, thank you for listening to our presentation, and we look forward to your discussion.